Welcome to Across the Globe. Today we will learn about error handling. Error handling is fundamental in programming to manage unexpected situations during code execution. In PHP, developers can employ try-catch blocks to execute code and catch exceptions. This enables the program to gracefully handle errors and prevent crashes. For instance, in a web application, if a database connection fails, using try-catch blocks can help display a user-friendly error message instead of a system error. By utilizing these error handling techniques, developers can enhance the robustness and reliability of their PHP applications. Exceptions in PHP are errors that arise during code execution. They are managed using try-catch blocks. When an exception is encountered, the program jumps to the nearest catch block that matches the exception type. This mechanism prevents the program from abruptly terminating. For instance, in a scenario where a file cannot be opened due to permission issues, an exception can be thrown and caught within a try-catch block to gracefully handle the error without causing the program to crash. The provided code snippet demonstrates a try-except block in Python to handle a zero division error. In this example, an attempt is made to divide 10 by 0. However, division by 0 is not defined in mathematics, leading to a zero division error. To prevent the program from crashing due to this error, the code within the try block is executed. If a zero division error occurs, the except block catches the exception and prints a custom error message, cannot divide by 0. Real-world scenario. Imagine a program that calculates average scores for a group of students. If the program encounters an error due to a division by 0, for instance, if a student's test score is missing, using a try-except block like the one shown can gracefully handle the zero division error, preventing the program from crashing and informing the user of the issue. PHP developers can enhance error handling by utilizing custom exceptions through the throw keyword. This capability enables the creation of tailored error messages and facilitates structured management of distinct error types. For example, a custom exception could be thrown when a database connection fails, providing detailed information for troubleshooting and resolving the issue efficiently. Error handling is like a safety net for a tightrope walker. If they lose their balance and fall, the safety net catches them and prevents them from crashing to the ground. Similarly, in programming, error handling is like a safety net that catches and manages any unexpected errors or bugs that occur during the execution of a program. Just as a tightrope walker must be prepared for the possibility of falling, developers must anticipate and plan for potential errors in their code by implementing error handling mechanisms. Without error handling, a program could crash or behave unpredictably when faced with unexpected issues, much like a tightrope walker falling without a safety net. Hey, code conquerors, ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance, coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. Low-level code utilizing error handling makes debugging and identifying problems easier. The PHP code snippet showcases a function, perform risky act, to replicate a tightrope walker's uncertain act. A conditional check is put in place to identify loss of balance below 0.5, triggering an exception via throw new exception. A try-catch construct encapsulates the function call, aiding in capturing and managing errors that may arise during the delicate performance. Upon encountering an error, the catch block prints a detailed message and executes specified error handling actions, like activating a safety net. Following execution, the finally block runs to signal the completion of the performance, encapsulating any cleanup tasks. Error handling within code is akin to the safety measures implemented by a tightrope walker, ensuring resilience and graceful recovery from unforeseen mishaps. In the automotive industry, error handling plays a crucial role in ensuring the safety and functionality of vehicles. One example is the implementation of error handling in autonomous driving systems. These systems rely on various sensors and algorithms to navigate roads and make decisions in real time. However, errors can occur due to sensor malfunctions, unpredictable road conditions, or software bugs. To mitigate potential risks, error handling mechanisms are built into the autonomous driving software. For instance, if a critical sensor fails to provide accurate data, or if there is a discrepancy in readings from multiple sensors, the system can detect the error and activate fail-safe measures. This may include safely pulling over the vehicle, alerting the driver, if present, and engaging backup systems to ensure the vehicle comes to a stop without endangering passengers or other road users. By implementing robust error handling strategies, automotive engineers can enhance the reliability and safety of autonomous driving systems, reducing the likelihood of accidents or malfunctions on the road. In the aviation industry, error handling is a fundamental aspect of ensuring the safety of aircraft operations. One critical application of error handling is in the aircraft's flight control systems, where any errors or malfunctions can have severe consequences. Modern aircraft are equipped with sophisticated fly-by-wire systems that rely on computerized controls to interpret pilot inputs and adjust flight surfaces accordingly. In the event of sensor failures, software glitches, or other unexpected errors, the flight control system must be able to detect, isolate, and recover from these issues to maintain the aircraft's stability and safety. For example, if an anomaly is detected in the airspeed sensor readings, or if there is a discrepancy in the data received from redundant sensors, the flight control system can engage built-in error handling mechanisms to mitigate the impact. This may involve switching to alternative sensors, adjusting control algorithms, or notifying the flight crew about the issue. By prioritizing error handling in aviation systems, aircraft manufacturers and operators can enhance the reliability and resilience of flight control systems, ensuring the safety of passengers and crew during all phases of flight. Across the globe, industries leverage error handling techniques to enhance the reliability and safety of their systems, whether it be in autonomous driving, aviation, or any other field where precision and accuracy are paramount. By incorporating robust error handling mechanisms, organizations can mitigate risks, prevent catastrophic failures, and maintain operational efficiency in the face of unexpected challenges. Keep learning, stay curious, and I'll catch you in the next video.